Okay, in the Math 4 exam review, we're on problem 2 still. We haven't worked C yet, so I'm working on C now. C looks a lot worse than A and B, but really, after the first step, it's not going to be any more difficult a problem. With the first step, what I want to do is get rid of those fractions, because what do you guys hate working with? You hate working with fractions. So the first thing I'm going to do is multiply through by a number that will eliminate my denominators. So if I look at the first equation, whoops, might need my pencil again. Look at the first equation, my denominators are 2 and 3. So the smallest number that they both divide into, or my least common denominator, is 6, and that's what I'm going to multiply that whole equation by. So when I multiply the first term, 2 goes into 6 3 times, so I have left 6 times the quantity x plus 4. I said that wrong, didn't I? 3 times the quantity. Wrote it right, said it wrong. 3 times the quantity x plus 4, because 2 divided into 6 3 times. That eliminated my denominator, and I multiplied 3 by my numerator. Equals. 3 divides into 6 2 times, so I have to multiply 2 by that numerator, and that's y plus 10. So now I'm going to go ahead and distribute that. That gives me 3x plus 12 equals 2y plus 10. And since my goal is to be able to use addition on this, I want to set them up so they look like this, where I have ax plus by equals c, constant on the right hand side. So I need to move over the 2y and move over the 12. So I'm going to subtract 2y, and that gives me 3x minus 2y, and now subtract over the 12 equals negative 2. Okay, you can do that step by step if you need to. Just pause your tape and get yourself there. Okay, so now I'm going to do the same thing with the bottom fraction. I'm going to look for my common denominator, which again happens to be 6. That doesn't have to happen that way. Just happened to here. So 2 divides into 6 3 times, and I have 3 times x. 6 divides into 6 one time, so I have 1 times 2y plus 8, which is of course 2y plus 8. So now again, here was my first equation after I got rid of my denominator. I want it to be in that order. So I need to move over the 2y and leave the 8. So that gives me 3x minus 2y equals 8. Okay, so that one's set up right. And I just noticed, and I'll bet some of you already noticed, I made a mistake up here. When I distributed that, I said 2 times y is 2y and 2 times 10 is 10. That should have been 20. Congratulations to those of you who caught my mistake. Since you're not in the room with me, you couldn't say anything, but I bet some of you were saying she's going to get the wrong answer. So now when I subtracted 12 from 20, I didn't get negative 2. I got positive 8. So now, look what I have here. My first equation is 3x minus 2y equals 8. And my second equation is 3x minus 2y equals 8. And I bet some of you know what the answer is already. If you do recognize that because my equations are both the same, if I went to graph them on both of them, obviously I would graph exactly the same line if they're exactly the same equation. That means one graph lies on top of the other, and my answer to that must be, who knows? I bet there's somebody out there, if we were in class together, who could tell me that that means I have infinitely many solutions. Infinitely many solutions. And that means for any x I pick, the y that goes with it would be the same on both of those equations. Okay, again, congratulations to anyone who figured out that I had made a mistake in the middle of that last problem, caught me before I moved on. But we did get it figured out correctly before we finished the problem. Okay, number 3 says solve using a system of equations in 2 variables. So if you remember, in Math 3 you learned how to do this all in 1 variable. Now we're using 2 variables, so we've got to write ourselves a system of equations, which means 2 equations. So let's start out with what we know the formula for a perimeter of a rectangle is. We have a rectangle. So there's my rectangle, and we know that it has a width and a length. And when I'm looking for the perimeter, I know I can say it's either 2 times the length plus 2 times the width, or I could say the perimeter is 2 times the length plus the width. You can use either one of those equations that you want to use. It doesn't make any difference. Now, since it gave me what the perimeter is, I can say 2 times the length plus 2 times the width is equal to the perimeter 20, or I could have put it in that same order. Or again, I could have put it over there. So there's my first equation. And now it also tells me that the length of a rectangle is 4 feet longer than the width. This length is 4 feet more than this. So that means my length would be my width plus 4, right? So my length is equal to my width plus 4 more than that, because it's 4 feet longer. So right here are my two equations. So I want to look at those two equations and decide which method that I've already learned does this lend itself to solve. Remember, the methods we've done so far are graphing. Well, I certainly don't want to graph this. Substitution, which I can use if one of my variables is already solved for. Well, I can use it if one isn't, but it's easiest if one is. So that's a good choice. Or I can use addition. Since this is set up this way, I think I'm going to go with substitution. So I'm going to choose substitution. Whoops. S-U-B. I didn't write that very well. Let's not leave that mess on there. I'm going to use substitution as my method for solving. So that means I've said that L is W plus 4. So I'm going to go to my equation, and where there's an L, I'm going to put W plus 4. So I have 2 times W plus 4 plus 2W equals 20. So that's 2W plus 8 plus 2W equals 20. 2W plus 2W is 4W plus 8 equals 20. Subtract the 8, and 4W equals 12. So W is 3. Okay, so remember, I used substitution. I have to use it a second time. I'm going to take that W and plug it into that equation. That gives me my length equals 3 plus 4, or my length equals 7. It said find the dimensions, so the dimensions would be 7 times 3, or 7 by 3. Or you could say my length is 7 feet and my width is 3 feet. Or again, the dimensions are 7 by 3. Okay? And those are, remember, when you, I'm saying this wrong, when you're solving a word problem, you always have to answer what they asked for. So I obviously would not want to put my answer here the way I did before when I was giving you an ordered pair solution where the two lines cross. I don't want to put this as an ordered pair. I want to answer the question, so it's either 7 by 3 or length is 7 and width is 3. Either one of those would be perfectly fine.